Okay team, welcome to video 2, which is going to look at 3b and adding and subtracting surds. To start with, I actually just want us to focus on this statement here, which says simplify, and it says 3a plus 2b minus 3b plus 4a. Now, I'm sure you'll all agree with me with looking at that. We can only add things which are like terms, and so our 3a and our 4a are like terms, and I've highlighted the addition sign in front of the 4a because that'll belong to it. And then our 2b and then our minus 3b, those are our friends there. Now, if we wanted to, we could rewrite this and put the things that are friends together. So we could say 3a plus 4a minus 2b, plus 2b minus 3b. And if I collect all of that, my final answer would be 7a minus b. Now, what we've done there with algebra, we have collected our like terms before we've added or subtracted them, and we actually need to do the same thing with like surds. So a like surd is a multiple of the same surd. So I've got some examples here for us that root 2, then 2 root 2, and then also root 18, which could be rewritten as 3 root 2. They are all like surds because they all have root 2 as their surd, and perhaps they have a different coefficient out the front. And that means we can add or subtract them. For us to be able to do this though, we actually need to simplify all of our surds before we add or subtract them, so we can get them down to those bases that can't be simplified any further. So we can get them down to like a root 2 base, a root 3 base, maybe a root 5, maybe a root 6, for example. So we've got to still use those skills from 3a to simplify our surds before we continue on and answer the questions. So I have some examples for us to start with, okay? If we look at question 1 here, I've got root 2 plus 2 root 2. Now remember, technically there'd be like a little coefficient 1 out the front there. That's a funky 1, but anyway, there'd be a little 1 out the front there. And so if we're writing our answer here, I've got 1 root 2 plus 2 root 2, so I can say my answer here would be 3 root 2. If we direct our attention over to b then, b is more complex. We can see here that we've got 2 root 5 minus 2 root 2 plus 7 root 5 plus 5 root 2. And so we've got different bases of our surds. Some are a root 5, some are a root 2. And so to start with then, we might actually want to collect things based on what their like surds are. So I'm going to rewrite this. I'm going to keep 2 root 5 out the front, but I'm then going to collect the plus 7 root 5 because they are like surds, they're friends. And then I've got minus 2 root 2 and plus 5 root 2. So I can only simplify surds that have the same surd there. So 2 root 5 plus 7 root 5 becomes 9 root 5 for me. And then if I focus on the second part of the equation, negative 2 root 2 plus 5 root 2 becomes for me plus 3 root 2. And that way I've simplified those surds. If you like, you can just go straight to here with the answer if you want. But if you do need to put in that step of rearranging them so you can see which ones are friends and which ones are like surds, then rewrite it yourself. We start to get a little bit more complex here with C and D because we've got ones where we actually need to simplify first of all. And what I will say to you is perhaps there's a bit of a clue of what the other surd should be. So maybe you're trying to look for, say with C, we've got root 8 plus 2 root 2. Maybe we're trying to convert root 8 to be something root 2, okay? If we think about our multiples of 8 though, we could say 1 times 8, 2 times 4. So I'm going to simplify this first of all to be root 4 root 2 plus 2 root 2. And then we know that 4 simplifies to be whole number 2, so root 8 can be rewritten as 2 root 2. And I'm still adding on this second 2 root 2. And now I can just add those two coefficients at the front to have 4 lots of root 2 there. D is more complex because I've got bigger numbers under my surd. So I've got root 6 minus 2 root 24 plus 3 root 96. but remember I said this might be a hint to us. So let's look at 24 and 96 as multiples of 6, okay? To start with, I'm just going to leave root 6 here. I've got minus root 2. Hopefully you agree with me that root 24 could be rewritten as root 4 root 6. And 96, if you look at what times 6 gives us 96, it's actually 16. So root 16, root 6. I can now say root 6 minus 2. Root 4 simplifies to be 2, so this is going to be 2 times 2 root 6 plus, sorry, that's got a bit funky, 3 root 16 simplifies just to be 4. So I can say 3 times 4 and then root 6. And now I can do all those little multiplications. So this is going to be minus 4 root 6 plus 12 root 6. And now all my surds are like surds. They're all root 6. And I can just focus on adding all those coefficients at the front. So I know like technically there's a 1 in there. So I've got 1 minus 4 plus 12. Or you can think of it as 12 minus 4 is 8. 8 plus 1 gives me 9 root 6. Another thing is, if you like, you can go from here straight to there if you like. So if in your head you can simplify root 4 to be 2 and just go straight away, 2 times 2 gives me 4, and here 3 times 4 gives me 12. You can do that in one step if you like as well. The final one here is just a little different. It's got a fraction for us, and so I've got root 5 over 4 plus root 5 over 3. We know that if I'm going to add fractions together, they need to have a common denominator, so I actually need to cross multiply my fractions first of all. And if I'm going to do that, it means over this side I need to multiply, oh sorry, my pen's funny, both the numerator and the denominator by 3. And on the right hand side I need to multiply both things by 4. So if I now do that, my numerator is 3 root 5 over 4 times 3, which is 12, plus 4 root 5 over 3 times 4, which is also 12. And now that my fractions have the same denominator, I can just merge them together. My numerators are surds that have the same surd, they're both root 5, so I can simplify this to be 7 root 5 over 12, and the coefficients of 7 and 12 don't simplify anymore there. I hope that was helpful to explain it to you. Remember that if you're going to add or subtract the surds, it needs to be the same number under the surd symbol. So I can add x plus 2 root x and tell me that's 3 root x. But if I had root x plus 2 root y, that would actually still end up being the same thing because I can't add root x and root y together. So just bear that in mind as you go through those questions. And remember to always simplify your surds so that you have them as the smallest possible form, and that should help you with adding and subtracting them. Thank you.